Hello and good evening, CTS266 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CCNP Switch course, and this evening's video tutorial is going to be on Discovery Activity number 2, where we're going to ease our way into configuring VLANs and trunks. And we're going to be taking a look not only at some standard range VLANs, but also the extended range VLANs, and we'll have a conversation about some of the reserve VLANs that you are not able to use. And so again, this is a great activity to ease our way in here. So let's go ahead, we'll kick off with step one, I should say. And it wants us to take a look here at PC1. And as you can see, what we're going to try to do here is the setup is going to be where we've got PC1 is going to be in a specific VLAN, PC2 will be in a VLAN, same with 3 and 4. This will be ultimately our trunk link right here, and we're going to get VLAN communication across the trunk link. Now, I didn't say inter-VLAN communication, but I said communication within the VLANs. Remember, to have that inter-VLAN communication, we would have to have a multi-layer switch or a router somewhere to make that happen. And I don't believe that these are going to be, or we're not going to be using them as multi-layer switches, because we're dealing with the trunk. And remember, the trunk is a layer 2 construct. So when we're talking about trunk links, we're talking about a layer 2 construct. All right. So let's go ahead, and I'm actually going to thin that line out a little bit. Okay. All right. So it wants us to start out on PC1. So let's jump onto PC1 here. And we're going to go from user exec into privilege exec. And again, the PC, they call them PCs, but it's actually the Cisco's IOU. It's iOS on Unix. So it's not really like a Windows PC per se. So it just gives us something to use so we can test our connectivity here. So we're going to try to ping 192.168.1.101. And as you can see, the first ping failed. Now remember, the first ping fails because it has to ARP out for the address. There's the address resolution protocol. And so what happens is PC1 says, well, I know the address that I'm trying to go to. It's 192.168.1.101. But I don't have any of the layer 2 information that's required to make that happen. So if we go on to switch 1 here, let's go from user exec to privilege exec. If I say show MAC address table and I hit enter, you can see that we've got two dynamic entries here. Ethernet 01 and 02. Well, it just so happens that Ethernet 01 is PC1. And so what had to happen was that PC1 had to ARP and say, hey, here's the layer 3 address. I'm trying to get to 192.168.1.101. Can anybody help me and give me the layer 2 address, which is going to be the MAC address, the destination MAC address for PC2. And you'll notice that PC2 sits here on Ethernet 02, and if we look at switch 1, you can see there is, and let me get the whole entry here, we're in VLAN 1, and there's the whole entry for PC2. So now that the entry is in the switch, and again, if I were to say show MAC address table, the entry is definitely in the switch. If I come back now, you'll notice that we don't lose any pings. So good news, we've got connectivity between PC1 and PC2. Okay, so let's go to step 2 now in our discovery activity. We're going to ping from PC3 to PC4. So here we're going to be pinging from PC3 over to PC4. Now, they're connected to the same switch, switch 2, and they're in Ethernet 01 and 02 as well. So let's jump on to switch 2 real quick. Before we do anything, let's show MAC address table. So there we go, and we've got Ethernet 01, so here's PC3, and Ethernet 02, and there's PC4. Now, just taking a look here in that far right-hand column, in fact, let me go ahead and flip over to the pencil here. this far right-hand column over here, you can see something that's sort of like one of these kids is not like the other. So take a look at the VLAN assignment for port Ethernet 02. So it shows that PC4 is actually in VLAN 20. And PC3, which is on Ethernet 01, is in VLAN 1. And so remember, a very good way to remember that a VLAN is a subnet, is a broadcast domain, right? So a VLAN is a subnet, is a broadcast domain. And what that means is that inside of a VLAN, a virtual local area network, that your broadcast traffic is not going to make its way to other VLANs. So in other words, broadcasts that take place in VLAN 20 are not going to show up in VLAN 1 or VLAN 10. And so that broadcast domain, which is the VLAN, which is the subnet, which is that network, is contained within that VLAN. And so let's go ahead and prove that right now, that we're not going to be able to have inter-VLAN communication yet. And I don't believe in this lab that we are. We're actually trying to prove this point right here, which is the VLANs are mutually exclusive from each other. So there'll be no cross-pollination, there'll be no communication between the VLANs. And so to prove that, let's go ahead and pull up PC3 here. And on PC3, we'll go from user exec mode to privilege exec, and we'll simply say ping 192.168.20.110. And so we might be thinking, okay, maybe it's ARPing out, maybe we'll lose one packet, possibly two. But we don't. We lose all 5 of those packets. And again, the reason for that is that these two PCs are in VLAN 1. And these two PCs over here are in different VLANs. In fact, let me go ahead and change my color up here, and we'll stick with blue. So we'll go outline this guy in blue. So this is VLAN 20, and this is VLAN 1. And so that port right there is going to be VLAN 1, and this port right here is in VLAN 20. And so these two devices are on separate logical networks. They're in the same physical switch, but we've created a virtual local area network, right? And I say we created 20. 1 is your default, right? So VLAN 1 is the default, oops, sorry about that, is the default VLAN. So we created VLAN 20 and we put PC4 in there, and now he is isolated. He cannot speak with any of these other PCs who are in VLAN 1, because VLAN 1 is its own virtual local area network. VLAN 20 is also its own virtual local area network. So in VLAN 20, if there are broadcasts, they are not going to be seen by devices over here in VLAN 1. Unicast traffic won't be seen by devices in VLAN 1. Multicast traffic won't be seen, because again, VLAN 20 is completely separate from VLAN 1. And remember, we're not talking about inter-VLAN routing yet, which is where we can configure things so that VLAN 20 can speak with VLAN 1. Right now, we're trying to really reinforce the fact that these VLANs are mutually exclusive constructs, where what's going on in VLAN 20 is not affecting what's going on in VLAN 1. Okay. So let's go ahead and clear the screen here and switch back to the cursor. And again, that concept of a VLAN is a broadcast domain, is a subnet, is an independent LAN network. So it's its own construct. All right, so here's what we're going to do. So on switch 1, we're going to go ahead and we're going to create VLAN 20 because that VLAN doesn't exist. So what are some of the commands that we can run? So let's say show VLAN, and I'll do a question mark, and you can see I can type in brief, I could type in all ports, I could try to put the name in, I could put in the port number if I wanted to. So let's just say show VLAN and hit enter. And what do we see here? Well, we see that we have a single VLAN, and it's VLAN 1, and it looks like pretty much all of the ports are in VLAN 1 right now. So how do we create a VLAN? Well, we go from privilege exec to global config, and we simply say VLAN, and we put the number of the VLAN. Now you'll notice that it drops me into a VLAN sub-configuration mode. So if I were to do a question mark here, you could see that we can shut the VLAN down. And when you work with a parking lot VLAN, you'll hear this term, I'm going to use this term quite a bit over the next week, the parking lot VLAN, which is a VLAN that you would create, that you would put ports that are not being used into the parking lot VLAN. So in other words, the concept is that I'm not using ports 1 through 5. So what I'm going to do is I'm going to put those ports into the parking lot, and they'll sit in the parking lot VLAN until we're ready to take them out of the parking lot to use them for something. And the best practice and something that I do is always shut down the parking lot VLAN. And so this is where you would shut the VLAN down. What we're interested in is the name. So you can provide an ASCII name for your VLAN by simply saying name, and if I do question mark, you can see here it says the ASCII name for the VLAN. So by default, the VLAN would take a name like, and if we can scroll back up here, you can see it would just simply be 1002. Well, it would say VLAN followed by 020, right? If I didn't give it a name. So if I were to say do show VLAN, and let's see if the VLAN shows up right here. You'll notice the VLAN's still not there because I'm configuring the VLAN right now. I would actually have to exit out and see how it says applying VLAN changes may take a few minutes, please wait. So until you exit out, the VLAN is not going to show up. And this is also true if you're on real Cisco equipment. So if I transition here for a brief second over to a 2950 that I have, if I go into privilege exec and I go into global config and I say, sorry, not name, if I say VLAN 20, and see, I'll do the question mark here, you can see we've got many of the same choices, and I say name, and then I put down the name, and we'll just call this test VLAN. Or I'm sorry, before I name it, when I say end, and then I say show VLAN, you can see that the VLAN shows up, and it just has this name VLAN 0020. So it's basically VLAN followed by 4 characters, and the reason there's 4 characters here is because you can go from VLAN 1, right, all the way up to VLAN 4094. Now, remember, the standard range VLANs are 1 to 1005. And I say 1005 because I said standard range, right? So not usable, just standard range is 1 to 1005. Keeping in mind that, and let me draw this out here on the side for you really quick. So when we talk about the VLANs, so VLAN 1 to 1005, that is the standard range. Now, VLANs 1002 to 1005 are for FDDI and token ring. So you will, and I'll say never, but you'll never see these used. But they're still there for backward compatibility. The extended range VLANs go from 1006 up to 4094. And so let's go ahead and say these are the extended range. And we'll talk about these a little bit more when we get to VTP, the VLAN trunking protocol, as well as VTP version 3, or specifically VTP version 3, excuse me, and making the switch a transparent switch. So those are the extended ranges. So now you're probably wondering, well, what about 0 and what about 4095? So these are reserved. So those are reserved, and you can't see them. You'll never see these, but they're reserved, right? And they're used by the switch itself. So again, here are the different ranges. Again, remember I said standard range, right? So don't be confused. 1002 to 1005. Again, these are legacy. You can see right here for FDDI and token ring, right? And so those just simply are not used, but they still fall within the definition of the standard range. So really what we're saying when we say standard range usable, you would say 1 to 1001. And then 1002 to 1005 are locked up right here. And then you pick up at 1006. And we'll also talk about the VLAN internal usage policy ascending as well as we transition here as to where these will also, these extended range VLANs will also be used. So let me go ahead and clear the screen here. All right. So if I were to create another VLAN, let's say VLAN 30, and say do show VLAN, you'll notice that the VLAN doesn't show up. It won't show up until I exit out of the configuration mode for the VLAN. You can see right here, now it does show up. So it's the same with the IOU that we're using here. Now, we don't see this applying VLAN changes, excuse me, but that's again just because we're on Cisco IOU. So now when I say show VLAN, you can see that VLAN 20 does show up, except the name, while definitely accurate in terms of what it represents, could be spruced up a little bit, and so I think they're using IT here. So I would simply go back in and say VLAN 20 and simply say name IT. So now what happens when I say do show VLAN? You'll notice the name still has not changed, and why not? You've got it, because I'm still in VLAN configuration mode. I have to exit from VLAN configuration mode, and again, it's nice that you give you the little message there. Do show VLAN, and let's say show VLAN brief, which doesn't show me all of this additional information down here. And you can see that now the name has been changed. So the name is now IT. All right, so we have just created our own VLAN, subnet, broadcast domain network, right? So remember that. A VLAN is a subnet, is a broadcast domain, is its own little network. And we've just created that on switch 1. And remember that VLAN 20 already exists over on switch 2. Now, we're talking about configuring a port to belong to a certain VLAN. There's two ways to do it. You can do it statically, or you could do it dynamically. So the dynamic approach is pretty much off the table from a curriculum perspective. And if you were to do it dynamically, just to briefly talk about it, is instead of going to a port, and if I were to come over here back to switch 2, and let's say show run interface, and we want Ethernet 02, you could see that right here we say switchport access VLAN 20. Well, if I was doing dynamic VLAN configuration, I would have, there's a couple things that I would need. The first thing that I would need would be and let's change this color up here, I don't like blue on the black. We would need a VLAN management server, right? VLAN management policy server of some kind, which would be used to track the MAC to VLAN assignments. And my A's aren't coming out too good there. So we would need a VLAN management policy server to track the MAC to VLAN assignments, because it's in this database where I would go in and I would say, okay, anywhere in my layer 2 infrastructure where I see the MAC address A, B, B, and what do we have here? CC00, and what is that? 6 echo 0, and that looks like a C. 6 echo 0, 0. I would say that belongs to VLAN 20. And so this VLAN management policy server would contain all of the entries so that dynamically you could plug in to any access port, and the VLAN management policy server will simply look up the MAC address it sees on the port. When it receives that first layer 2 frame, it looks at the source MAC address, and it would say, I'm seeing this MAC address. Yep, I'm putting that port into VLAN 20. And so that's how you would approach it dynamically. Our focus in the course is going to be on static VLAN configuration. And what you see right here, this is static VLAN configuration because of that line right there. Switchport access VLAN 20, which is where we're putting a port and we're hard coding it into a VLAN. Now, when we're talking about access ports, which is what we have right here, an access port can only pass traffic for one VLAN. So in other words, there's no way for me to come in here and say switchport access VLAN 20, switchport access VLAN 30, or 20, 30, 40, 50. An access port, and you notice I'm stressing that, the access port, which is different than the trunk port, the access port can only pass traffic for a single VLAN. Okay. Excuse me. All right, so let me go ahead and clear the screen here. And so again, we're focused on static VLAN configurations. All right, so what we're going to do now is on switch 1, we're going to go into interface Ethernet 01. So we're going to be taking a look at this interface right here on switch 1, Ethernet 02. So for PC2, I apologize. So for PC2, we're going to be taking a look at Ethernet 02 here. And let's see, do show run interface Ethernet 02. What does that look like right now? Well, as you can see, Ethernet 02 is just basically duplex auto, right? So it's auto negotiating the speed, but then there's no other configuration that's currently set up. So what does that tell you? So a couple quick things here. Remember that if you were to take this Cisco switch or any Cisco switch out of the box, the default VLAN and the only VLAN that will be on there is going to be VLAN 1. And as you can see, every single port is a member of the active VLAN, and it is the default VLAN, and you cannot delete this VLAN, and you can't remove it, and it is the default, and I don't believe you can rename it either. So I'll give that a try here in a second, but it is the default, and so everything out of the box brand new is going to be in VLAN 1. So if I had 10 hosts that I plugged into a switch that I had literally just taken out of the box and thrown on the table, they're all going to be able to communicate with each other because they're all in the same VLAN. Now, one of the concepts that for new learners can be a little confusing is, well, hold on, Travis, you just told me that we were doing static VLAN configuration. So where is the line here that says switchport mode access? How is it possible that this port has a host plugged into it and it doesn't have a line like the other, like when we looked on switch 2? And for that matter, where is the switchport access VLAN 1? How is it that this is working right now? Because remember, this was PC 2. PC 1 is in 01, and they were able to ping each other. You remember that, right? They were able to ping each other. So how is that possible without any of this configuration on there? And the answer to that, which is going to lead us into a conversation about the dynamic trunking protocol, is that one of the things that you'll find also with switches, and we'll address, so let's address this first. There's no switch port mode access. So then how is this working as an access port? By default, the switch, and we're going to take a look at a command here in a second, show interface, and then we'll put the interface number in, and then switch port, you're going to see that the operational mode will negotiate and figure out something was just plugged in here in a 02. Does it want to be a trunk port? What are we doing? And then it will negotiate to a status of access. By default, it'll negotiate to a status of access if we plug an in-host into it, which is why with switches that are using the dynamic trunking protocol that are set to dynamic auto, when you plug them in together, they don't negotiate as trunk ports, they actually show as access ports, operationally as access ports. So that answers this here, is that if I don't do anything else, I pull the switch out of the box, plug my host into it, it will auto-magically turn into an access port, and this is the default. And so remember what I've said in some of my other videos is with Cisco, the defaults usually don't show up here. And even if we configured specifically that switch port access VLAN 1, it's not going to show up because that's the default. And Cisco typically, with settings that are default settings, does not put the setting into the configuration. So it will not show when you do a show run. So let's go ahead and clear the screen here. Let me do the little squeegee. And we'll bring this back. So if I were to say interface Ethernet 02, and if I were to say switch port access VLAN 1, and then say do show run interface Ethernet 02, it doesn't show up. Again, because that's the default setting. Now we're going to get to one of the commands, and this is definitely a command you want to have at the ready and in your arsenal when it comes to your CCNP exam, and that is do show interfaces, and I'll say Ethernet 02, and whoops, a little quick, Ethernet 02 switch port. So do show interface, the name of the interface, and then switch port. And so let's take a look here at what we've got, and this is always interesting output because, and actually, where did that just go? I think I slid over it there. There we go. Sorry for that. All right. So this is always interesting output because this tells the entire story of the port and what's going on. And this should be your go-to when you're trying to figure out, you know, what is up with the port. And maybe there's an issue. So what do we start with? Well, we start with the name, and we already know that because we've provided that. But if you were to say show interface as switch port, it'll show you every, this status right here will be shown for every port on the switch. So now the next one is enabled, which means we've got something plugged into it, it's enabled. Now the administrative mode, think of the difference between, you'll notice it says administrative mode and operational mode. And it says it for, it says administrative mode and operational mode, and then it says administrative trunking encapsulation, and then operational trunking encapsulation. So let's focus right here on administrative mode is dynamic desirable. And what administrative mode means is what was it initially set to? In other words, did it, you know, if an administrator set something, or is it the default? But that is just the administrative mode is what it was set to. Well, we see here that this is dynamic desirable. And there are two modes we're going to be dealing with, dynamic desirable and dynamic auto. So this is set to dynamic desirable, and we'll talk a little more about DTP as we go on. But what this mode means is that it is actively trying to negotiate a trunk port. Now, remember, I told you what happens is, if I plugged a switch in to this port, they would definitely form a trunk port, because this guy's dynamic desirable, and the guy on the other side, if he is auto or desirable, and again, we're talking about DTP, we're not talking about hard coding it yet. We're just saying with dynamic trunking protocol, with dynamic desirable, he will be able to form a trunk successfully if the other side is either desirable or auto. So one side has to be desirable, because think of it like this. The desirable side is saying, hey, I want to form a trunk, let's be a trunk. Hey, I want to form a trunk, let's be a trunk. The auto side is kind of like the passive. So if it's passive aggressive, auto is passive, where he's kind of sitting there saying, well, if you want to be a trunk, I'll be a trunk. And the desirable side is being the aggressor. He's saying, let's be a trunk, let's be a trunk. So if both sides are saying, let's be a trunk, they're going to be a trunk. If one side is saying, let's be a trunk, and the other side says, well, if you want to be a trunk, I'll do a trunk, then you're going to have a trunk. Now, if both sides are auto with dynamic trunking protocol, you will not get a trunk. No trunk. And now I'm out in the white where it's tough to see. So if it's auto on both sides, you won't get a trunk. Now this is very, very important, because, and I think this is interesting, so in IOU, you'll notice it's desirable. If I pop out here for a second and we come over to this 2950 real quick, I'll leave the yellow there because it's not interfering too much. And if I were to say show run, and we were to take a look at some of the ports here, you can see that, and actually I did make a change to this, and that's okay, though we've got some other switches here. Let's take a look at this guy here. So if I were to say show run, and we come down, you'll notice that there's no configuration on any of these ports. So what's the command that we would use to really find out behind the scenes what is going on with this port? What are the settings right now? Well, I would say show interfaces, fast Ethernet 101 switch port. All right, so, and let me squeegee this off here real quick. We'll have to recreate that a little later. So, but again, here we see that once again, we have the name, we have the fact it's enabled, right? The administrative mode is dynamic auto. Now, this is a 3750. So it's not that old of a switch. It is pretty old. But there's some history, because you're probably asking yourself, well, why is it dynamic auto on this switch, but on the Cisco IOU we saw it's dynamic desirable? Well, as recently as the 3550s, Cisco's physical 3550 switch, they were set, the default was, let's put DES for desirable. They were set to dynamic desirable. And typically what happens is Cisco listens to a lot of the feedback they get from their customers. And the feedback that they received was that having the port actively trying to negotiate a trunk link by default is a huge security no-no. And so it was after the 3550 line where they changed their minds and said, you know what, we've listened to the community, we hear what you're saying, we're going to go ahead and set it to administrative mode out of the box as dynamic auto. And remember what I said, this is the passive side of the passive aggressive. So if you hooked in two switches that were auto, they're both going to sit there and go, well, do you want, I can't remember what I was saying. So for the passive side, it's like, well, if you want to be a trunk, I'll be a trunk. And then the other side says, well, if you want to be a trunk, I'll be a trunk. And then that's all they say to each other. And they never form a trunk relationship because both sides are auto. So this was a little tweak. But this command, show interfaces switch port, gives you the details as to what's going on. And so you can also see right here that it's going to try to negotiate the trunking encapsulation as well. And we'll talk about ISL and 802.1q soon. You can see that the negotiation of trunking is on. And here is the other part of our equation. The access mode VLAN. It's set to 1, which is the default, which is why all of the ports are in VLAN 1 by default. You actually have to create other VLANs with other VLAN numbers in order to put the ports into a VLAN other than 1. All right, so let's go ahead and transition back here to the lab, and let's finish up step 5, which is we're going to get into interface Ethernet 02, and we're going to say switch port mode access. Now, remember, the administrative mode was dynamic desirable. The operational mode, because it couldn't negotiate a trunk, it just simply falls back to an access port, which is why we were able to put 0 configuration on there, and PC1 and PC2 are pinging each other, and everything is working great. Because by default, those are going to become access ports, and they're going to be in VLAN 1 together. So I'm going to say switch port mode access, but now let's take a look at what the port reports now. So take a look now at the administrative mode. It is now a static access because, again, I have administratively made a change to the switch and said switch port mode access. So there has been an administrative change making this an access port. Now, operationally, a host is plugged in, so it is a static access port because we have set it to be a static access port. So now it's no longer trying to negotiate trunking. And where's our proof of that? It is right there. So negotiation of trunking is off because we've said this is no longer to be treated as a trunk port. And a quick note, all ports, or I should say all switches by default, all ports on switches by default, catalyst switches, are trunk ports. All the ports on the switches are trunk ports. We actually have to trick or configure a switch port to be an access port. If you didn't do that, all the ports are set up to be trunk ports, right? It's only when we decide I need to put an end host in there that we configure it as an access port. Okay, so again, you can clearly see that the operational mode is static access, the administrative mode, because we've configured it to be an access port, is now access as well. All right, so if I were to then put them into the correct VLAN, we'll say switch port access VLAN 20. And let's see what happens to the access mode VLAN. Does that change? So let's check it out. Switch port access VLAN 20. Let's come back in and take a look. And what do we... moved over it there. Sorry about that. And what do we see? Well, not only do we see that it's VLAN 20, it carries the name with it as well. So we know right away it's in VLAN 20, but I might not remember what VLAN 20 is. The name is right there for me, IT. So then I can say, oh, that's right, this is in our IT VLAN. So the next step, step 6, says we are going to change the we're going to change the IP address on PC2 because right now PC2 has an IP that is in VLAN 1. So let's take a look at that. Show IP interface brief. Excuse me. There you go. 192.168.1.101. Let's go into global config. And I'm going to go into interface Ethernet 00, and we're going to say IP address 192.168.20. And it has 101 here. I'll do 99. And we'll say 255.255.255.0. And let's see, and that is it. All right, so we've made the change. We've given it an IP address in the broadcast domain, in the VLAN, in the subnet, right? Remember, a VLAN is a subnet, is a broadcast domain, is its own individual network, right? So now let's go back to switch 1 here, and let's say do show VLAN. And there you can see we've got VLAN 20. It is active, and the port has been moved in here. So Ethernet 02, after we said switch port access VLAN 20, now shows up here. So if I were to try to keep up here, so it shows us the name, right? So remember we said I can say do show VLAN name IT, and then it will only show me the information for that VLAN. Now, what's interesting here? What do we see that we didn't see just a second ago? It shows Ethernet 1.1. So if I come back to the diagram, where is Ethernet 1.1? Well, Ethernet 1.1 is right here, and it runs between switch 1 and switch 2. Now, these were both dynamic desirable, and I'm assuming the one was. We didn't look at the other, but I'm assuming by default it's going to be set to dynamic desirable. So what kind of a link do we have here? Exactly, we've got a trunk link. And so we're going to get to that in just a second. Let's wrap up here. We did the show VLAN name. And now it wants us to ping from PC1 to PC3. So we're going to ping from PC1 on the left over to PC3 on the right. And before we do that, let's go ahead and say do show interfaces, oops, trunk. And this is some very good output right here, and this is also a fantastic command to definitely have at your disposal. So here we go, Ethernet 1.1. The mode is desirable, so the other side can be desirable or it could be auto. But we know that it's negotiating things, right? And that is what that little N right there stands for, which means the encapsulation was negotiated as ISL. Now, a quick note, ISL is Cisco proprietary, it's legacy, and in fact, on the newer Cisco switches, the 3850s and the 3650s, that is not even an option that you can pick when setting your trunking encapsulation. So remember, the N stands for negotiated, which means that we didn't hard code it, that the switches worked it out between the two of them, and the order is it will try to negotiate ISL first, right? So remember that. It's going to try to negotiate ISL and then 802.1q, and then it will fall back to an access port, which is what we've seen happen, right? When we on the PC2 connection to Ethernet 02. It tried to do ISL, but the PC doesn't speak ISL. It tried to do 802.1q. The PC doesn't speak that either. So then the switch port says, all right, well then I'll just go into static access mode. Now, what's the status? We are trunking. The native VLAN, we're going to get to that soon. So then we've got VLANs allowed on the trunk, and this is, again, 1 through 4094. Remember, 0 and 4095 are reserved and cannot be used. So VLANs allowed and active in the management domain. So what are the VLANs that we have configured? Well, we've got VLAN 1 and 20. That's it. 1 was there by default, 20 we configured on our own. And now this may be the most important, especially when you start talking about troubleshooting why you don't have connectivity across switches. So VLANs in spanning tree forwarding state and not pruned. So we've got to have it in the forwarding state or else it's not going to be forwarding traffic in that VLAN. And we don't want it pruned because if it's pruned, that also means that we're not going to be getting the traffic for it. So this last set here, or this last bit of output, is extremely important. And typically, if you're having issues with traffic between switches, I always like to come and look here to see maybe there's a switchport VLAN allowed on the trunk link that is excluding the VLAN that I'm in and causing me not to have connectivity. So again, remember that in is it's been negotiated because we are using DTP, Dynamic Trunking Protocol. And this is desirable. My guess is that the other side is also desirable. And we'll check that here in a second. So now we're back to switch 1, and we're going to ping between PC1 and PC3. And this should work, right? So let's go ahead and give it a go. Ping 192.168.1.110. We're going to have to ARP, I'm sure. And there we go. And there were 2 ARPs because we probably had to go, we went across the trunk link into another switch. So we've got the 2 ARP packets that, or the 2 ping packets, the ICMP packets that drop, but then we've got success. Now, subsequent attempts, everything is going to work just fine. All right. Now remember, the reason that that's working is because they are in the same layer 2 virtual local area network. And basically, again, we're just taking the switch, which is one big network, right? All the ports are in VLAN 1, and we're creating virtual, smaller networks on that switch. So now let's try to ping from PC2 to PC4. So let's get back on PC2 here. So we'll say do ping 192.168.20.110. And let's see what happens here. So it says the ping should not be successful. And let me make sure I got this right. It says between PC1 switch 1 says access link carries only data for VLAN 1. Ah. Okay, it says the ping should not be successful because the link between switch 1 and switch 2 is an access link and carries only data for VLAN 1. So let's check that out, because let's go over to switch 2 that we haven't seen here. Let's say show interface trunk, and it is definitely set to desirable mode, and the status is trunking, and it's forwarding for VLAN 20. So let me see, show run interface Ethernet, I think it was 02. Oh, Ethernet 1.2. Sorry about that. Ethernet 1.2. And duplex auto, so it is a trunk link. So it's definitely not an access port. Show interfaces, Ethernet 1.2 switch port. No, the operational mode is trunk. It is not an access port. And it's ISL. And we haven't touched PC4 yet. Let's take a look at, let's see what Ethernet 02, short interface Ethernet 02, I think we just saw that. So it's an access port as well. Let's take a look at PC4 and say show IP interface brief. And it is up. Let's see, am I missing something here? Switch 1, switch 2. Oh, okay, so it wants us to change the encapsulation to .1Q. However, and this is interesting, those are definitely not access ports between switch 1 and switch 2. So I'm curious as to why I don't have reachability. 192.168.1 or .20, sorry, 20.99. So if I try to go from 4 over to 2, it doesn't work. And I'm hard pressed to see that this would be set up to not work, or to force us to set it to 802.1Q. So we'll go ahead and follow through with that. But right now, this should be working because we are trunking, and we looked on both sides. It is a trunk port, and it should be carrying traffic for both of those VLANs. Okay, but we'll go along here, and so let's go ahead and set this to so it's an interface Ethernet 1.1, and we're going to say switchport trunk encapsulation .1q. Now, what I like to do is, that's a whole lot of typing right there. If you're typing it out, I simply say switchport TED, T-E-D. So it's trunk encapsulation .1q. That's all you have to type to do switchport trunk encapsulation .1q. And then we're going to say switchport trunk allowed VLAN 1,20, and then switchport mode trunk. So let's take a look and see when I say, and did not leave the current state trunk. Yeah, so it may be an issue because the other side is not hard-coded. When I say switchport mode trunk, we've hard-coded this port as a trunk. So if I say do show interfaces Ethernet 1.1 switchport, what do we see now? Well, the administrative mode, and that was when I said switchport mode trunk. As soon as I said that, I have set the administrative mode to be a trunk. The operational mode is that it is trunking because, excuse me, because we have it set as a trunk. The administrative trunking in cap, so the administrator or someone set .1q. The operational is going to be .1q, and this is the Ethertype, and we'll talk about the packet and where you see the Ethertype in the layer 2 or the 802.1q, and I've drawn a complete blank right now. The 802.1q tag is what I wanted to say, and the Ethertype is in the tag. In fact, it's the first field that comes right after the destination source. It comes after the source MAC address in the layer 2 frame. And the first thing you see in that tag, which is 4 bytes, is the Ethertype. Then you have the priority, and then you've got the, what I like to call the token ring field, which is 0 if it's, I'm trying to remember, 0 if it's token ring or if it's 1. I probably have to go back to my notes. And yeah, 0 is Ethernet, and 1 is token ring in that field. And we'll draw this out in a second. Then you've got the VLAN ID, which is the last 12 bits. All right. So now you'll notice it says negotiation of trunking is on, right? So we've hard-coded it, but all that means is it is trying to negotiate to be a trunk, and we've told it, we've hard-coded it to say you are a trunk, so try to negotiate to be a trunk. So let's go ahead onto the other side here. Let's go over to switch 2. Actually, let's take a look at the diagram. Ethernet 1.2. So we're going to go into global config, interface Ethernet 1.2. Let's say do show run interface Ethernet 1.2. All right. So let's go ahead and go into, we're in the interface, so we're going to say switchport trunk encapsulation .1q, right? Switchport trunk allowed VLANs, and we're going to say 1 and 20, and then switchport. And to show what's going to change here, again, do show interfaces Ethernet 1.2 switchport. You can see what it says right now. The administrative mode is dynamic desirable. Well, watch what happens when we say switchport mode trunk. Run that command again. The administrative mode is now trunk because an administrator, someone has administratively changed the mode of the port to trunk. Okay, so do show run interface Ethernet 1.2. So there's the configuration on that port. Let me double check here. Yeah, so 1.2 is correct. So now if I say do show interfaces trunk, we're going to see something different. Instead of mode desirable, we see mode on. And what this means is we have hard-coded the port with that switchport mode trunk. We have turned it, we've turned it on as a trunk port. Now in the encapsulation, we see 802.1q, but there's no N before it because again, we've hard-coded the encapsulation we wish to use. Now, same thing applies here. You'll notice we have the same VLANs are in the spanning tree setup, and the status is it's trunking, so we have a good trunk port there. The native VLAN is still 1. We haven't changed that. So let's see now if what they're going to be looking for is, or actually let me talk real quickly about the let's get the pen up here. Real quickly about the tag. So ISL, Cisco's old proprietary trunking protocol, would encapsulate the entire layer 2 frame with an ISL header at the beginning. And then you would have the rest of your information in the frame. What 802.1q does, and 802.1q is the standard, and it definitely is preferable, especially if you're going to be doing any trunking between non-Cisco devices. Remember, ISL is proprietary, and it's pretty much dead. You should not see ISL, and you shouldn't be using ISL today anyway. And again, like I said, it's not really a choice. So the tag in the Ethernet frame, and let me try to do my best rendition here of what that would look like. All right, so you have, and this is the this will say this is our layer 2 frame, right? Whoops, left out the A. Layer 2 frame. So you have your destination MAC address, followed by your source MAC address, followed by, and I'm going to leave a little space here. So this is the frame untouched, and this is where our tag will sit. And this is the 802.1q tag that gives us that trunking information. And then we have the length, or the Ethertype. And then we have data, the actual data inside the layer 2 frame. And then you have your frame check sequence, right? It does a CR, cyclical redundancy check, just to make sure that everything is okay with the frame. Now, if you just imagine for a minute that this is not here, that's what the frame would look like. As soon as we use 802.1q, it inserts a tag right after the source address. And so what is in that tag? The tag is 4 bytes in size. And what sits in that tag? Well, if we take a look here, we have the first field is the, and I'll not spell this whole thing out, it's the Ethertype, right? And that is 0x8100, and we saw that over on, I don't know if we still see it. No, it's just right up above that right there. But the Ethertype 0x8100, this indicates that the frame is an 802.1q frame. What follows are your, and that's a PRI for priority. So this would be if we were doing any type of QoS, quality of service. And then the next field is the, what I call the token ring field. It also goes by this other name, CFI. And I'm definitely not going to draw or spell the entire acronym out. It's Canonical Format Identifier. And basically, this field, if it's a 0, that means it's an Ethernet frame. And you're going to see it's going to be 0. It'll be an Ethernet frame. If it was 1, it would be token ring. And you might only find that in the Stone Ages. So not much token ring left out there anymore. And then the last, and this is definitely not drawn to scale, is the VLAN ID, and that is the last 12 bits. And so that's how 802.1q, and again, I'll do this here. So that tag, this is the tag right here. And that's what 802.1q does, and that's how it communicates the information as to what the VLAN ID is for a layer 2 frame that's crossing a trunk link. And that's it. You'll have your destination MAC, you'll have your source MAC, you've got your tag field where the switches will look in here and say, aha, I'm dealing with 802.1q, no QoS. It's set to the CFI field, the token ring field is set to 0, means it's an Ethernet frame. And then the last 12 bits tell me that when this frame reaches the other side of the trunk link, that this is the VLAN into which I'm going to place this frame. And again, it's this VLAN ID right here, when this frame reaches the other side of the trunk, that is looked at to then determine, is the destination MAC address in that VLAN? And it should be, and because that's why it's being sent over to the other side of that trunk link, right? Because remember that the VLAN is going to contain that MAC address. So the VLAN ID will be going to, or the VLAN ID will contain the destination MAC address. I said that the destination VLAN is going to have the MAC address that's in the destination field here. And so this VLAN ID field, when this frame reaches the other side of the trunk link, that's what tells the switch, put this frame, i.e. this traffic, into this VLAN. Okay, so go ahead and screenshot that now if you wanted to. I'm going to go ahead and clear the screen here. So that's our layer 2 frame, and that's what it looks like with the 802.1q tag inserted into the VLAN frame. So now the last thing it says is to issue a ping from PC2 to PC4. Now I still maintain that this should have worked. It should have worked with ISL. There's no reason that this shouldn't have worked. We should miss 2 pings and then it works. Okay, so again, it wasn't an access port, unless maybe there's something with this specific exercise that it's waiting, or it's set up, it's sort of pre-canned, but that should have worked. The trunking was functional, the VLANs were both there, it was forwarding for both VLANs, but in the end, we flipped it to 802.1q, which is what you want to have. That's what you should have, and you should be using 802.1q because it is the open standard which all of the vendors support. HP, Huawei, Juniper, Arista, they all support 802.1q. All right, so this is sort of going to wrap up the activity. Again, to summarize, we have PC1 and PC3 in the same VLAN, VLAN 1, the default VLAN. Out of the box, you throw the switch on the table, every port is in VLAN 1. And actually, one critical piece of information I want to touch on here, and this, it was kind of funny. This is a question that always comes up, show VLAN brief. So here's my question to you, and actually this is not, I'm not breaking any what's that, non-disclosure agreement, because when I took this, I took the CCNA like back in 2002 or something like that. I took a very long time ago, and one of the questions that I was faced with, and I'm sure the question's not around today, but again, this is from like 2002, and the book actually covers this, but it covers it with a gray note section, kind of very innocuously in the middle of a page somewhere. So let me ask you this. When we look at the diagram, and we see that on switch 1, Ethernet 1.1 is the port that goes over to Ethernet 1.2 on switch 2. So my question to you is, where is Ethernet 1.1? We've got 000103 1012. What happened here? Where is Ethernet 1.1? Right? And this is, like I said, I actually use this question a lot on my quizzes because you don't see it here. And so remember, if you list out the ports and you're expecting to see a port and you don't see it, what kind of a port do you think it is? Exactly. It's a trunk port. And again, I don't think I've broken any NDAs. It's a 20-year-old question. So, and like I said, I use the question myself a lot. But again, it's to get you to recognize that if you don't see the port here in that show VLAN brief, chances are it's a trunk port. And in our case, it is. If we were to go over to switch 2, so if I were to squeegee the screen here and head over to switch 2 and say for Ethernet 1.2, do show VLAN brief, where is 1.2? And this is even more demonstrative here, right? Because it goes from 1.1 to 1.3. So where is 1.2? Well, it's not going to show up here because it is a trunk port. These, right, would all negotiate out to access ports, so they are not trunk ports. When they do become trunks, they will no longer show up here. All right, well, this wraps up a really nice activity to ease us into VLANs, trunks, and getting communication across trunk links, and really keep that show interfaces, Ethernet, whatever, switch port command, keep that at the ready, as well as show interfaces trunk. All right, guys, thanks for watching, and I will see you all on Monday night.